Now we know we're recording. Okay, so today's learning target is I can make a tape diagram using ratios and unit rates. Start out by labeling your paper. Here we go. I'm going to start out by calling this classwork homework. And basically, I am using some problems from the classwork homework to help you start with the notes and then kind of create your classwork homework with it. We are going to be doing something called a tape diagram. And all tape diagrams is a way to model. It's going to kind of pull, like I want you to imagine a piece of duct tape or a piece of scotch tape and it pulling across, making equivalent rates and ratios. Okay?
What's scotch tape?
I have no.
Yesterday was the 26th.
Okay. As far as I know, it is the 27th. So, okay, here we go. Now, when doing a tape diagram, you are going to be going from a rate to a unit rate to a different rate. And I want you to think about this. Unit rate, before the break, unit rate meant how much is? 1. That's the key to the unit rate, is how much is 1. Okay. Now, before we started, I gave you this page 178. I just want to kind of show you where I'm pulling this problem from. Okay, the very top. We're just going to start with this one. Kind of using this one to teach you. It says, Jill and Sammy are racing go-karts. Jill completed 6 laps in 12 minutes. If Sammy raced at the same rate, how many minutes did it take her to complete 3 laps? Now, the key to this is you might already know the answer because we've already taught rates and unit rates. Now we've got to learn how to model them or how to draw the tape diagrams. So, using this information, I'm getting ready to kind of write it out. I'm going to start it out by writing it as a proportional model. And Jill's rate right there in the math problem was that she could do, let's see, 6 laps in 12 minutes. So, 12 minutes, 6 laps. Okay. Sure. Now, on the ending rate for Sammy, it said at the same rate, how many did she do in 3 laps? Okay. That right there kind of being where your answer should be. Okay. Now, I want you to think about this. You've done this part before. If we are going from 12 minutes and 6 laps, how much is 1 lap? What is it, guys? 2 minutes in 1 lap. So does everybody agree to that? That's our unit rate. So if we're going to go from 1 lap to 3 laps, we're going to multiply by 3. 2 times 3 is 6 minutes. Now, I realize that we already know the answer. But the key is now we've got to learn to draw these tape diagrams. Now, I would start with watching me for just a second on how I draw this first part. Okay? We have to start out by drawing a tape diagram to represent Jill. And the way the tape diagram is drawn, you might want to watch for just a second. Looks like this. And you're going to put the laps on the bottom. The key is you're trying to get 6 boxes and try to get them the same width. Okay? You want 6 boxes for her 6 laps and try to make the 6 on the bottom, the 6 boxes, the same size. Okay? We then have to label it. Each box stands for 1 lap. And I realize it's kind of redundant to write lap over and over, but we have to. So 6 laps, and Jill did that in 12 minutes. So what you've just done right here is created a tape diagram to represent the rate of Jill. This is a representation or a model of what Jill did with her laps. What they want us to do is create a tape diagram now of Sammy and show how they are basically equivalent or equal. Okay? Now, up here in your little proportional model, Sammy had 3 laps. Does everybody see that? So we need to find, we need to only draw for Sammy 3 laps. You only want 3 boxes. The goal is try to make the boxes the same as the boxes that Jill had. You're trying to show that they are equivalent rates. Okay, I'll give you a second. Go ahead. Do the best you can. Listen, this is the hard part, and it just takes some practice. That's why I was saying earlier, you're going to have to do this homework in order to know what to do, and just practice drawing these things. Okay, Sammy had 3 laps, so I'm going to write 1 lap in each little box because that's what it's representing. Okay. And I'm not grading you on perfect boxes, but I do need to see some decent equivalence here. Try to make them the same. Okay. Now, the key is, this is Jill's rate. I need you to think about her unit rate. So how much, if Jill can go 6 laps in 12 minutes, how much is each lap? How many minutes? 2. So each little box here is 2 minutes. This is kind of like what's going on in my head, meaning I realize that it's 2 minutes for each box. So if I transfer that thinking down here, 2 minutes in each box, what is Sammy's total minutes? 6. Is Sammy's total minutes. This is kind of like the final answer, but I have to grade for all of this. Now, you don't have to write the little 2 minutes in each box, but if it helps you to do that, that's fine. I do not mind. I do not mind. Okay? Yes, and I want you to think about that question. That's a good question. Because basically, when you did the math of 6 into 12, or 12 divided by 6, and that unit rate, like we did up here, is 2 to 1. Once you think about it, is every box 2? Yeah, but that's a good question, because if one was 3, we wouldn't get 12 minutes. Okay?
So it'll be like 6 times 2.
Yes. Yes. And listen, all you're showing is that this is the same as that. These are two rates. They're the same. I want you to think about it. What if you simplified it to 1 lap? It's what? 2 to 1, right? It's the same thing. There are 3 different, it's just like equivalent fractions. 1/2 is the same as 2/4, which is the same as 3/6. Okay? So, let's do number 1 down here on the bottom of 178. This is the actual classwork homework. So everybody kind of see where I'm at down here? Okay. Number 1 says, suppose it took Jill 18 minutes to complete 6 laps. How many minutes would it take Sammy to complete 3 laps? If she raced at the same rate as Jill. Now, I want you to think about what they mean by that. At the same rate, and this kind of goes back to your question about the minutes. What this is meaning is these two people are literally taking off and running at the same exact speed. Nobody tripped and fell. Nobody needed to stop and tie their shoe. It is literally the same speed. Okay? That's why each box is equivalent. Does that help a little bit? Okay. So, here we go. I'm going to show you. Let's do number 1 together. This is right off the classwork homework. Here we go. Okay. Now, number 1. Here we go. I'm going to first set it up with my proportional model just so I kind of have my numbers on my piece of paper. Jill did here we go. Jill's right. She did 18 minutes in 6 laps. So what if Sammy did 3 laps? Okay. In the middle, kind of like we need to find this unit rate. So, how much is 1 lap? 3 minutes, that's right. And we use division, right? 18 divided by 6. So 3 minutes for 1 lap. How many would be 3 laps? What's Sammy's rate? 9 minutes, you got it. Okay. So that is my kind of proportional model, or my math problem, as I'm going to call it. Okay. Now I'm going to draw my tape diagrams. That is what number 1 is wanting out of us. So here we go. Jill. I just usually start by drawing a pretty long box. Like that. I notice that Jill has 6 laps on this one. That means I need 6 boxes on the bottom. So, 6 on the bottom. 1, 2, 3, 4, 5, 6. Just doing the best I can, getting my boxes the same. Okay, I get to write 1 lap 6 times. And this is represented in 18 minutes. Okay, everything good? Okay. Now I'm going to do Sammy's tape diagram here on the bottom. Now, the key is Sammy only needs 3 laps. Just 3. So I need to stop at that 3rd box make my tape diagram stop at that third box. Try to make the boxes the same width as up here. Okay, so if 6 laps in 18 minutes, we already said that that would be 3 minutes in each cute little box. That is your unit rate. So if 3 minutes were in each box here, how many total minutes?
9.
9, you got it. Okay. And I'm grading for this. This is that modeling. Drawing the picture. You kind of need to do both in a way. This is the main thing. The key is going to be, especially on the homework, each question is different. So I'm going to keep doing a few with you on the homework. Like right now, if you would like to eat your snack at the same time, that is fine. But please try to stay with me. Okay. But I'm going to show you. Some of them are wordy questions, as I'll call it, where we need to write words. Some will be drawing the tape diagrams. Okay? If you are watching this video, this is my 3rd period class that gets to eat snack. So, ignore the crunching. Okay, here we go. Number 2. I'm going to move on. So, why not, right? Here we go. Now, on number 2, it says, explain how you can use unit rates to solve for missing measures in equivalent ratio problems. And I want you to think about this because we've already talked about this. It says, explain how you can use unit rate. How do we use a unit rate to solve for equivalent ratio problems? I want you to think about that.
You get down to 1, and then so you can add up to what's
That is right. So we use the unit rate to make a new rate, is the way I think of it. We have to find the unit rate to, I call it create or make a new rate. And that new rate is the equivalent ratio. I mean, it's the same thing. Now, I am currently doing the homework with you, so I'm hoping you're writing this down, 3rd period, because if parents happen to watch this and realize, wait a minute, so Miss Donahue did these with you, and then you don't have it, that might not be good. Anyway, yes? That, honestly, this is just something that requires paper. It's just a lot of drawing. It's a lot of drawing. Today and tomorrow is a lot of drawing. Yes? Oh, 1 second. Let me make that a little smaller so you can actually see it. How about that? Does that help? I'm just trying to, like, to me, an equivalent rate is the same as an equivalent ratio. They're equal. That's the key to it. Okay, I'm going to go on to number 3 now. Number 3, they already gave you the tape diagram. They just want us to answer questions. So it says, a 5-ounce package of snack mix has 250 calories. How many calories are in 3 ounces of the same snack mix? So I want you to look at this. If 5 ounces are 250 calories, how much is each ounce, each little box? $250 divided by, look again, 1 minute. first we got to get this unit rate. So 250 divided by 5. Okay, so how many calories are in each box? 50, right? Does that make sense that, like, each one of these is 50? Okay, so if each one is 50, how much is 3 of them? 150, right? 150. So, for number 3, we need to write 150 calories. Okay. One second.
Is that bad, 150 calories?
Not well, just matters. Right here. So, like, if you have 250 calories, and you're trying to find out how much is 1 ounce, but they have 5 of them, you're finding that unit rate. So 5 into 250 would be 50 each. 50 calories per ounce. So if 1 ounce is 50, 50 plus 50 plus 50 would be the 150. Does that help a little bit? Yeah? Okay, so making sure. Okay, so let's look at number 4. Number 4 says, a cleaning solution requires 2 capfuls of cleaner for 8 quarts of water. So once you think about it, little capfuls, you're pouring it into a bucket of water. Okay. How many quarts of water are needed for 6 capfuls of cleaner? Now start out with this one. If 8 quarts take 1 capful, how many quarts is 1 capful?
4.
I'm sorry, 2 capfuls, but now how much? 4. So if 4 quarts per capful, 4, 8, 12, 16.
It's 12.
What is 6 times 4?
24.
24.
No, it's 12. 24.
24
6 times 4.
quarts
Okay.
is going to be how many capfuls?
Bro, do you know your top 10?
4.
Yes, I do.
24 quarts. Okay. Now, going on to number 5. 5 through 9 is where we're going to start drawing the tape diagrams. Okay? That's, well, I'm trying to get to number 5. Here we go. It says, a football player ran 100 yards in 10 seconds. How many yards can he run in 4 seconds at the same rate? So, and I realize you might have the answer, but we got to draw the tape diagrams. That's the whole thing here. So here we go. The first rate, I'll call it rate 1, is 100 yards in 10 seconds. Now, I would be writing this down because it is helping you to get that final answer. Do you what? Oh, yeah. Some of these are not exactly realistic. Okay, so if he can do 100 yards in 10 seconds, how much can he do in 1 second? 10, right. 10 yards in 1 second. I know they're not exactly real world numbers. Just go with it. Okay, so what if he ran 4 seconds? This is kind of like our new rate. Or rate 2, the new one, whatever you want to call it. Uh-huh. I'll have to go back to those in a minute. So, if 1 second is 10 yards, how much is 4 seconds?
4 yards.
40 yards. Okay. Now, I'm going to draw my tape diagrams. I'm going to start with this first one. Rate 1. Okay. I just usually draw them all long. It doesn't really matter. Now I need 10 seconds on the box, on the bottom. So I need 10 boxes. And I know they won't be perfect. Do the best you can. Label each one 1 second. I hope you're keeping up with me so that you don't have so much homework. Okay, and this person does the 10 seconds is 100 yards. Please be writing this down. No, I'll go back to those in a minute. I hate to say, but I showed them earlier. I'll show them in a second when I get done with this one. If 1 second is 100 yards, if 10 seconds is 100 yards, 1 second is 10 yards. So each box is worth 10 yards. No, that's just kind of what we need to be thinking about. So if rate 2, we need 4 seconds. So I'm going to go down to 4. I'm going to label it with my seconds on the bottom. So if each box is worth 10, then we know that the answer is 40. Okay. Now, this is the way you complete 5 through 9, and then, 6 through 9, and then 10 and 11 are just regular answer questions, like with a number answer. Okay. Now, I will shrink it down for my... There's 2 through 5 if you need them. Okay. So you are finishing through number 11, and I want you to try 10 and 11.